Hey, it's Michael from Arc Smarter. I recently got a question from a student in my Dynamo Dojo course about getting room dimensions using Dynamo. So he's working on some test fits and he wants to automatically display the room's length and width in the room tag. Now this is pretty straightforward to do using bounding boxes, but things get really complicated and fall off the rails quick when you have irregularly shaped rooms or rooms that are rotated. Now you can end up with incorrect dimensions as bounding boxes typically orient to the view rather than the room geometry. Not good. But I looked around and I found a couple of little used out-of-the-box nodes that solve the problem for me nicely. What I ended up with is an elegant solution that works for pretty much any room. So how did I do it? Well, keep watching to find out as I take you step by step through my solution. So I'm here in Revit 2025 and you can see I've got a kind of weird looking floor plan here. I have 4 rooms. A couple of them are just normal shaped. I've got this one with a little kink on it here. And then in this other room, I have the corner cut off. And then I have a couple of columns placed in the middle of the room, and then as well as a column that's kind of embedded in the wall. And everything, all the rooms here are rotated at some random angle. So not particularly good design. Don't knock me for that. But what this will illustrate is just some issues that we run into when we try to get room dimensions. So what I want to do is I want to display the room, just the overall length and width of the room as part of the room tag. So I'm using a room tag here that will display text that's in the comments field. So if I go into the room, I'm just going to go into comments just to demonstrate. I'm going to say room dims go here. So that's going to display the room dimension. So whatever that height and width is will show up right below that. So I'm going to use that comments field in this example as a place to put the room dimensions. Now we're going to use Dynamo to calculate and actually get the room dimensions. So let's switch on over into Dynamo and get started on that. So the first thing we're going to want to do in Dynamo is get all of our rooms. So I'm going to go into the Revit library. I'm going to go down to selection and I'm going to just grab some nodes that we're going to need out of this one. So we're going to use the all elements of category to get our nodes. Then we're going to use, I'm going to right click, do a search, and the node that I want is the category.byname. So we're going to use that node here. We're going to connect category from category by name into all elements of category. And then we're just going to provide the category name in a code block. So I'm going to type rooms. And I like using this combination because sometimes for version to version inside of Dynamo that the list of categories changes. So if I use the categories node right here, there's no guarantee that what I select for rooms is going to be consistent in the previous or future versions of Dynamo. So a lot of times it's best to just hard code that category name. So if I give this a run, this is going to give me all of my rooms. What's interesting is you'll see there's actually 10 rooms that are showing up here, but I only have 4 in my actual model. So in all likelihood, I have some unplaced rooms here. So I'm going to do a quick little combination of nodes just to make sure that we're only getting rooms that are placed. And the way I'm going to do this is by looking at the room area. So I'm going to go back to Revit Elements. And I'm going to scroll down to Room, and I'm going to take the area node right here. So we're going to use that as a way to filter out our unplaced rooms. Let's look at that. So you can see that now when I look at the area, a lot of these rooms have 0 for the area and a bunch, only 4 of them have an actual area. So we can use this as a way to find which are the rooms are placed or unplaced. So we're going to look specifically for the rooms where the area is greater than 0. I'm going to go into math operators and we want to use the greater than node here. So I'm going to take the room area and then in a code block I'm just going to put 0. So we're looking for, again, if it's greater than 0, that's going to give us a value of true, and if it's less than 0, it will give us a false. So I can see here this corresponds pretty well with my room areas. I have 3 falses, 4 trues, 3 falses. Good. So this is essentially our Boolean mask. So we can use a filter by Boolean mask node. I'm just going to do a search, filter by Boolean mask. And this is also found in the list library. So our mask is going to be coming out of our greater than node here. And what we want to filter is our all elements of category. You just bump that up. And let me just move this up to kind of keep things looking nice. I can close these preview windows as well. So when I give this a run, and when I look at my in list, so these are going to be the items where that value is true. I have my 4 rooms, and then I have 6 rooms here. So that should correspond to the rooms that have area right here in the in list, and then all the rooms with the 0 area, essentially the unplaced rooms, are going to have be part of that out list. All right, so that's our first step. We have our rooms. Now what we want to do is we want to start getting some of the information out of the room. Now I want to illustrate a point though before we get to that. And in fact, let me just do a little bit of housekeeping here. I'm going to group these nodes just so it makes it easy to understand what's what. We'll give this a name, get rooms, and filter for place rooms. I like to color code my groups as well, and I'll usually start with that leftmost color, and I kind of work and try to associate a color to a function. So this is our get kind of group of nodes. Now, one way that I could approach this problem of getting the room dimensions would be to use just a straight up bounding box. In fact, if I go to Revit Elements, Element, you'll see that there is a bounding box node here. So I'm going to use that node, and then I'm just going to use the filter by Boolean mask. We're going to use the in because those are the rooms that are placed, and I'll give this a run. And you'll see that it pops up in the background here in my preview a whole bunch of boxes, my bounding boxes. So if I switch to my preview, I can see that it's giving me these bounding boxes right here. Now I'm going to also add another node so that we can see the room boundaries relative to those bounding boxes. So that node, I'm going to go in room, and I'm looking for the finish boundary node. Let's see. Oh, sorry. I'm going to go room. I want to go element, Revit element room. And then you'll notice that under the question mark section, I have a bunch of different boundary related nodes. So center boundary, there's core boundary, core center, finish. So we're going to use finish because we want the kind of the inside dimensions of the room. So I'm going to place that here and then connect our filtered rooms to it. And I give that a run. So now I can see the boundaries of the rooms relative to those bounding boxes. And if we switch into our geometry preview, you can see we kind of have a problem here in that the bounding boxes are actually square, kind of relative to the view, but our room geometry is rotated. So if I were to use my bounding boxes in order to get the room dimensions, they're not going to be accurate because it's giving me, the bounding boxes are not rotated or aligned with the room. So the dimension, my height dimension for this room here is going to be incorrect because it's giving me sort of the highest point and the lowest point, but it's not aligned to the actual room. So this isn't going to work for me if I have rooms that are configured or rotated like that. So let's go back into node, and we're going to get rid of our bounding box node. Okay, we proved that's a dead end for us, but we still have our finish boundary. So we're going to use that finish boundary, and then we're going to use it with a similar bounding box node, but this one is oriented to the actual geometry. Now, before we can get to that point, though, we have to kind of prepare our room finish boundary. In fact, if we look at this, first thing we'll notice is I have 4 rooms, so I have 4 kind of sublists in here, but there are some additional lists as well. In fact, this first list, I can see I get 9 lines, then there's followed by 4 lines and 4 lines, and then I get to the next room that has 4 lines, and then all the subsequent rooms all have 4 lines. So I have a lot of nested lists in here, and in fact, this is due to this room here has some columns inside. So you'll see it's giving me the bounding, sort of the curves around the columns because they're room bounding. And then I have this other column that's embedded into the wall, and then I have this notch. So the geometry for this room here is a little bit more complicated. More often than not, we're going to have conditions like this rather than these just clean rooms. So what we're going to do is we're going to filter through this list to make sure that we only get that finish line boundary, regardless of what other room bounding elements we have in our list. So I'm going to go up into our list library, and I'm going to use the list first item. So that's going to be under inspect. So I'm going to take first item, and essentially when I'm getting the finish boundaries from the room, that first nested list is going to be that room finish boundary. Any of the subsequent sublists are typically going to be columns or other elements that are room bounding. So I know that that first sublist is going to be the one I want. I want that room bounding. So if I can use the first item, and you'll see we're going to have to do a little bit of work with levels in order to get the right item, but that's going to get me closer to what I want. So I'm going to click on that. That's our first item. When I click run, this is actually going to give me not the first item in every list, it's just going to get me those first items right here. So I can see here it's giving me, again, that all of the boundaries for that first room. And I want all of the boundaries, those finish boundaries of all the rooms. So I don't want just that first room. So if I change and I click on under lists, I'm going to say use levels. And again, I have nested lists in here for my room finish boundary. So I have to kind of sort through this in order to get the right thing, get the one that I want. So I'm going to change this to list level 3 because I have that kind of nesting. I want to get the first list in that third level right here, which is going to be this list here. And it's going to give me, oops, sorry, actually, if I go back to my original list, it's going to be that first list right here. Then I'm going to get this first list, that first list, and that one. So I'll give this a run. And now I can see that using level 3 has given me what I want. I'm getting this series of lines from the first room, then the lines for the second, the third, and the fourth. So those are the rooms that I want. Now, again, the node we're going to use to get bounding boxes is the oriented bounding box node. So I'm going to right click and let me see. Actually, I'll pull it up where it lives because it's kind of tucked away. So I'm going to go to geometry, modifiers, and then geometry. That's the subcategory. And down here in the question mark, I'm looking for this node right here, oriented bounding box. So you have to dig for it a little bit. So I'm going to click that, and you'll notice that the input for this is geometry. Now I could connect my first item output into that. And if I give it a run, what it's going to do is it's going to give me a bounding box around each of the individual curves. So I don't want that. I actually want to get the bounding box around each of the individual rooms. So what I need to do first is I need to group all of those curves that make up the room bounding. I need to group them into what we would call a polycurve. So, or a sort of the idea is a polyline. So it's a grouped series of lines. So to do that, I'm going to go again to geometry. We're going to go to curves and polycurve. And the node I'm looking for is the polycurve by joined lines. No, sorry, joined curve. So this one right here. So what this allows me to do is I input a series of lists of curves, and it is going to output for me polycurve for those. So I can click on each individual one, and I'll see where that polycurve is. So it took those individual curves that define the room boundary, and it joined them together into a polycurve. So now I have a single item. I can pass that on, a single item for each room. I can pass that into my geometry-oriented bounding box. If we give that a room, now I end up with my 4 bounding boxes. And if I look here, and let's switch to our geometry preview, I can see some of the, obviously the bounding boxes are coincident with our room geometry, but I can see for these two, the bounding box is aligned with that room. And same thing here for the ones that have not sort of parallel walls, I can see that bounding box. So it's unlike the regular bounding box, which is aligned to the view, this one is aligned to the geometry. So now we're much closer to being able to get decent, and good accurate room dimensions directly from the bounding box. All right, so I'm going to clean up some of these previews, and then we'll group our nodes. Let's move this one over here. We'll group these together. and then we'll get ready on getting our room dimensions. Okay, we'll group this. So this is where we're getting our room finish boundary. Okay, and we'll assign this a color. There we go. All right, now with our bounding boxes, in order to get the room dimension, this is where I found some nodes that I didn't know existed. They're kind of tucked away, but they were exactly what I was looking for. So I can take this bounding box and I can actually convert it to what's called a cuboid. And what's great about a cuboid is it has properties for length and width. So we're going to find that bounding box to cuboid node, and I believe, let's see if we can, I don't know if it's under, no, it's not under abstract. I think it might be under modifiers, geometry. We're just going to search it. So it is bounding box to cuboid. Kind of a weird word. Here it is. So it's in the, so it's in the geometry abstract bounding box, and then you'll see this node right here to cuboid. So I'm going to take my bounding box, I'm going to convert it into a cuboid, and now from my cuboid, I can get my length and my width. So to find that, again, these are tucked away, I think. So I'm going to look for cuboid. There is a cuboid subcategory. So cuboid is under geometry, solids, cuboid. I can see here is height, width, and length. We actually want width and length, not height. So I'll get rid of that because we're just dealing with kind of flat two-dimensional cuboids. So here's our cuboid right here. We took those bounding boxes, we converted them into cuboids. Now if I plug that in, I can get the length and the width of each of those cuboids. Essentially, those are going to give me the overall length and the overall width of my rooms. Now, one thing to note in this case, and this is going to be true of all kind of the automatic room dimension generation scripts, they're going to give you sort of the largest case. So if we look at this room here that has this kink, the sort of the height, the length, well, if we're going to say this is length, this is width, the width of the room is going to be at its highest point. So I don't really have an easy way to get the lowest point, so I'm going to have to always know that the height is going to be the sort of the highest point. And that's just one of those constraints that we're working in with this particular methodology. All right, so I can see the values here, and those look pretty good. I have this room has a height of 18, a length of 18, and then a width, looks like width here and 42. So they all look good, and we'll verify these in the model itself, but at first glance, these actually look like we're getting pretty decent values. And I can tell too from my bounding boxes that the bounding boxes are tight to the room geometry. All right, so let's group these nodes here, and we're really on the home stretch. We've got our rooms, we got a bounding box that actually corresponds to the geometry, and we got the length and the width. So we're now just going to format those and then push those parameter values into our rooms. All right, so we're going to get room bounding box, cuboid, and length and width. Length. Okay, good. One thing to note with our length and width, these values are coming out of the model in decimal feet. And you can see there's a really long decimal point after that. So we're going to want to format that so it's more readable. We don't want to just push that straight into our, we don't want to put that into our room. We want to format that a little bit. So first things first, because we have our length and width, I'm going to put these together into a list. So I'm going to go to list create, and I'm going to take length, add that in, and then we'll add another input for our list. Or add our width. Now I'm going to use a list transpose node, and because I want to get the lists I want to get the length and width side by side for each room. So right now I have a list of lengths and a list of widths. What instead I want the length and width for each room like that. So our transpose node just sort of flipped around the structure of that list. So instead of two lists containing 4 items, I have 4 lists containing 2 items. Okay, so that's good. Now we're going to do a conversion though. We want to convert the decimal numbers that we get for the length and width, and we want to convert those into strings. So for that, I'm going to use a node. Let's go down to, no, not string. We're going to look for, I'm going to do a search. This is the easiest way. It is a symbol node. So there's a symbol node. If we go into symbols, so it's under units, symbol. So units is the library, symbol is the category. We're going to use stringify fraction. So what this will do is take a decimal value, which is coming out of our list transpose. So we're going to take that decimal value. Our precision, we're going to set it to be 2. So we would just want to use 2 decimal points for this. And again, you could say I think we had 8 or 9 decimal points for precision. And then under symbol, we're going to select the unit value. So we're going to use the symbols node. Let's see. That should be somewhere in here, I think. Got to search for it. It's just called symbols, and it's a list of all, here it is. It's under utilities. We're using a lot of corners of the Dynamo node library. So I'm going to use symbols here. And I'm going to set this. You can see these are all the various kind of units that are available inside of Revit. I'm going to set this to feet. Let's see if we can find it. Here it is. Feet is our unit, and that's the symbol we're going to use inside as part of this conversion. So when I give this a run and take a look at it, you'll notice now that it's actually formatting that text. So what we had as 18.25, if we take a look, or close to that, 18.166, it's converting that to 18¼ feet. So the symbols is indicating what the unit symbol is going to be. And I can change that however I would need to. Okay, so far so good. We have our room dimensions in a more sort of user-friendly format. And our last step, and let's group these together, or our second to last step, what we're going to do is convert those individual strings into a single string, and then we're going to push it into our parameter. So let's do our group here. We will call this one join. No, we're not there yet. We'll convert dims to strings. Okay, let's do some color coding. We missed that step on the last one. I'm going to set that to a nice orange. We'll go, and I'm just picking colors as I go. All right, so we're going to first join our 2 strings into a single string. So we have that length and width string. We're going to convert those into a single one. And we're going to do that using a string.join node. So under string generate, I'm going to use the join node. And the string is going to be coming out of our stringify fraction. And then our separator, what we're going to use is just a string that has an X. So if we're doing our room dimensions, we want, our length, and then we're going to use an X by our width. So that's going to be our separator. So what we should end up with here, when we give this a run, is a series of a string that has our room dimensions as a single string, 18¼ feet by 42 feet, and so on and so forth down the line. Now this is coming out as a nested list, so I'm just going to use a flatten node here. We're just going to flatten that and remove the nesting from it. So pretty much the same thing, just without that nested list. All right, now we're on the home stretch. So let me group these ones, and we'll color that. Oh, let's use that nice blue color, and we'll call this join strings. Okay. So last step, what we want to do is then set this. Like I mentioned, the tag that we're using in the model is using the comments field. So it's looking at the comments field. And again, you could certainly set this up to use a shared parameter. I could even use 2 shared parameters, one for the length and one for the width. I'm keeping it simple here. We're just going to push it into the actual comments field so we don't have to use a shared parameter. But feel free to set that up however you want. So we're going to use the set parameter by name node. Let's do a quick search for that. Okay, so that's going to be how we're going to do it. We're going to take the output of our list flattened. That's going to be our value. I'm going to use a code block, and we're going to set the parameter of the comments parameter there. So we'll use that code block to describe the parameter name. And then our elements, we're going to go all the way back to the beginning and get our filter by Boolean mask. So I'm going to connect those. So let's give this a group. And then we're going to just call this set parameter. And we'll color code it. Looks good. And I'm going to give this a quick save. All right, so let's give it a test. I'm going to do a split screen in Revit. And I can see my rooms here. I'm going to go ahead and give this run. And you can see very quickly it generated those dimensions for me. So here is my 18.25 by 42. Let me do a quick test with some dimensions just to verify that I'm pretty close. So 18'2". So I could definitely configure this better. There's 42. I'm not sure I love the way that it's doing the decimals. I could definitely, because we get 33.5, that's, or 5.5. So it is rounding it kind of to the nearest fractional part. So that looks good. And that looks good. So I could certainly play with this output a little bit more and make that more accurate. Ideally, I'd like to get, 65 foot 5.5. But again, I can play with my stringify fraction, and I can change my symbol and get something that looks, a little bit more what I want. But I have all that control. The important thing is I'm getting those dimensions in here. And for example, if I were to change, let's see, we can change this, this wall here. I give this a run, and it's going to go ahead and update that. So now we have 26 instead of what we had previously. We'll verify that. Oh, because that's going to the highest point, and I'm getting 22 right here. So works out great. And again, the orientation of the room really doesn't matter because I'm using a bounding box that's oriented to the actual geometry. All right, so give this a try. Let me know what you think, and have some fun. Thanks. Thanks for watching. I hope you enjoyed this episode of How to Dynamo. If you did, go ahead and click the subscribe button to get more Revit automation tutorials. Also, check out my free Dynamo template using the link over there. This template contains 20 node groups for common Dynamo actions, and it'll save you a ton of time when you're creating your scripts. Just copy and paste the groups you want, and you're on your way. All right, that's all from me. I hope to see you soon. Bye.